All right, let's finish this part 1 off. Yes. A system of equations is shown. What is the solution x of y of the system of equations? Enter your number in a box, and notice how the box is giving you an answer in a coordinate point form, which is exactly what you'd expect. Now, this problem is a system of equations problem that's really dumbed down, because x is equal to 10. Well, so you know already that this is going to be 10. So then, if x is equal to 10, we need to figure out what y is equal to. So let's plug in 10 for x and solve for y. So we have 3 times 10 plus 5y is equal to 20. Well, 3 times 10 is 30, plus 5y is equal to 20, minus 30, minus 30. So we have 5y is equal to negative 10, divided by 5, divided by 5, and you get y is equal to negative 2. So the two lines will cross at 10, negative 2. All right, can't wait. I feel a drop-down menu question coming. I love the drop-down menu question, don't you? All right. Oh, it is. Look at that. 3 congruent figures are shown on the coordinate plane. I have figures 1, 2, and 3. And right away, I notice that all 3 figures are congruent because they all have the same side lengths and the same angle measurements and the same basic shape. So I know that we are not dealing with any dilations, because dilations would change the shape. I'm dealing with reflections, rotations, and translations. So, select a transformation from each drop-down menu to make the statement true. Figure 1 can be transformed into figure 2 by a reflection over the x-axis. Well, if that were true, it would end up somewhere around here. And it would be facing the correct way, but it wouldn't be in the right place. So we know that's not right. A rotation of 180 degrees about the origin. Well, that would give us the figure way down here. A rotation of 2 units to the left. Well, 2 units to the left is no, obviously not. So then I notice that we have this followed by, which means we have 2 translations. So if I go back to my original options, the reflection got us really close, right? And so if I reflected about the x-axis and then translated it to the right 2 spaces, well, that would give us something. So let's see if that's an option. 3 units to the right. Look at that. That would be great. Now, when you do this problem, I would expect that you would draw this out, draw out the reflection, and then notice that you are 1, 2, 3 spaces away from the figure number 2. All right, part B. Slide down the screen a little bit, or I guess I don't have to. Figure 3 can also be created by transforming figure 1 with a sequence of transformations. Select a transformation from each drop-down menu to make the statement true. Figure 1 can be transformed into figure 3 by, and remember we're going to have 2 options here. Reflection across the y-axis. So if I reflect it over the y-axis, I would get something that looked awfully similar to this. That probably doesn't help us, but I'll put option 1. Op 1, or a rotation of 90 degrees clockwise about the origin. Well, 90 degrees clockwise, so I'm going to draw this figure. Obviously, you wouldn't have to worry about drawing and manipulating on a computer. You would just turn your paper. So I put the origin there, and a 90 degree clockwise. That's going the same way as a clock. So that brings me, oh, that's looking pretty good, because now I can just flip it over the y-axis. I think that's going to be the one here, folks. So then, I reflect it over the x-axis, which I have an option here, because this going to here, that would be perfect. All right, great. Sell my figures. All right, number 13, lucky number 13. We have a multiple select question, and which expressions are equivalent to 3 to the negative 8th divided by 3 to the negative 4th. Now, you'll remember that when you're dividing numbers or bases with exponents, if the bases are the same, you will subtract the exponent. So I'm just going to go ahead and I'm going to do this problem. So I have a pen now. 3 to the negative 8th minus negative 4. Now, 8 minus negative 4, that's going to be equal to 3 to the negative 4th, because subtracting a negative is the same as adding a positive. So negative 8 plus 4 is negative 4. So this is my option. But you'll also remember that the rule says if I have a to the negative x, it's going to give me 1 over a to the x power. In other words, negative exponents give me fractions, not decimals, or give me fractions, but not negative numbers. So 3 to the negative 4th is also equal to 1 over 3 to the 4th. So these are equivalent statements based on this rule here. So let's see what options I have. You probably have already noticed some of them. Oh, look, there's my first option. My second option is right here. And so B and E should be your answers. All right. Number 14. The graph of a nonlinear function is shown on the coordinate plane. In the graph, y is a function of x. Of course, x is my domain, it is my independent variable, y is my dependent variable. When the input of the function is negative 4, what is the output? So input, again, is x, output is y. So if I go to x of negative 4, I go up. That would be 5, positive 5. So I would click 5. Moving on to the next problem, number 15. I'll get my big red dot out of the way. So the scatter plot is shown on the coordinate plane. Beautiful scatter plot, don't you think, Ben? Yeah, okay.
Yes.
Yes is the right answer. Which of these most closely approximates the line of best fit from the data scatter plot? Well, A is pretty close because it seems to go through the middle of the dots. I have approximately the same number above the line as I have below the line. B, not close. C, again, not close. B, too many are above, below, or C, too many are below. And then question D. Question D, again, too many of the dots are above the line. So clearly the answer has to be A. All right. Problem number 16. 16 is Jay's favorite number, isn't it?
What?
16 is your favorite number?
No, 17.
7. Oh, so close. 17. All right, so I'm going to draw a line. And I have an equation of y is equal to 1/3 x minus 3. And that is line S. And I have this cool menu right here. Look at this, folks. Line S, line T, and point P. So line S has a y-intercept of -3. Why do I know that? Well, because -3 is right here. That is my y-intercept. So I'm going to put a, ooh, look at that, a blue dot. Because line S is blue. Well, I need another point, and I see I have a slope of 1/3. So that means I have a rise of 1 and a run of 3. So let's go up 1, over 3, and put another blue dot. And when I put another blue dot, I magically get a line. It's a nice blue line, isn't it? All right, so then moving on to line T. If I want to do line T, I have to click line T. And I have a y-intercept of +5. So I go up to 5, and oh my goodness, I get a red dot because line T is red.
Sure.
It is. and it has a slope of -1, because what am I multiplying x by? I'm multiplying x by -1. So it's a rise. So I have a rise of -1 and a run of 1. So I go down 1 over 1, and ooh, look at that. And now I have a line, a nice red line, which is Clark's favorite color.
Okay.
All right, and then finally it tells me that for point P, line A will be drawn through the points, select P, and plot P on the chords. And line P, okay, the system right here, I'm right here. So the system, the equations of line S and T form a system of equations. The solution to the system of equations is located at point P. And the solution is where 2 points, 2 lines intersect.
Oh, yeah, we're going
Right about here. And there's point P. No, you cannot. But if you wait for a little bit, that's a little weird, Seth. If you want to sit, Cooper, if you want to sit and wait, I am almost done.
I'll watch.
You can watch. All right. So, next problem. Number 17, which is Jay's favorite number, number 17.
Well, it is his favorite number.
All right. Classify each equation as defining y as a linear or nonlinear function of x. And we know that linear expressions can be written in several different ways, but most common is y equals mx plus b. No exponents whatsoever, and we're not going to divide by a variable either. So anything with an exponent, not so good. Oh, look. Does this first one have an exponent?
Yes.
No. Therefore, it is linear. And it doesn't have the variable x in the denominator.
Next one does have an exponent.
Oh, it does. See, because you're taking x to the second. That's nonlinear. Mr. Ferris, unless you want to hang out here.
Sorry.
This x is taken to the second power, so that is nonlinear. This is
linear.
It's clearly linear because it's y equals mx plus b form.
Is that is?
Well, let me ask you this. Is x being taken to an exponent?
No.
Is x in the denominator of the fraction?
No.
Oh, so really,
Yeah.
this can be rewritten as saying y is equal to 1/2 x. What's your slope here?
1/2.
1/2. What's your y-intercept?
0.
That's linear, folks. Clearly linear. And finally, this one is not even linear, that you can't even, no. Definitely Kmart, definitely. All right, 2 more to go. We're almost there. We are loading. Oh my goodness gracious. We need to solve for x. And this is not a fill-in-the-blank option. This is one that I have to type out. And it tells me to enter your answer in the space provided and enter only your solution. All right. Is it asking me to show my work?
No.
Yes.
It says only enter your
It
answer.
says only enter your answer.
But you should show your work on a piece of paper.
You should. That's
should
exactly
do
right. You
work.
should write it down and give your answer the way they want. So I don't have to type in my work, thank goodness. But I better write it out and do the problem. So let's do that. So first thing I'm going to do is I am going to.
Solve for x in that equation.
There are a couple ways I could do this. I will go with the easier to understand. I'm going to distribute. And so I would end up with 2/5 x. What's negative 10 times 1/5? That would be negative 2.
2.5.
Negative
2.
Negative 2, because 10 divided by 5 is 2. Plus 4x is equal to negative 3/5 x minus 12. Now, again, the fractions are not pretty, but they're okay. This is not too bad. And we need to combine the x's together so they can have a
common.
they can have a party. The x's want to get together.
Yeah.
All right, so
Triangle.
I noticed that I do have 4x and then a 2/5 x, and I have a negative 3/5 x here. Let's move that negative 3/5 x first, and let's see what happens. So what's the opposite of negative 3/5 x?
Negative 5/3.
Positive 3/5 x. So I'll add 3/5 x to both sides, and I will get, oh, look, I get 1 whole.
1x
I get
minus
1x minus 2. Isn't that brilliant? I get rid of the fraction right then and there. What is x plus 4x?
5x.
That is 5x. So I have 5x minus 2 is equal to negative 12. Add 2, add 2. It is this is a thing of beauty. This is a beautiful problem.
10.
So I have 5x is equal
And
to
divided by
10.
5 gets you 1. 10 divided by 5 is 2. X equals 2.
X does equal 2. Way to go. All right. But wait a second.
You must enter your solution in the box provided.
We have made a slight mistake. What is the error?
Train tracks.
No. What is negative 12 plus 2?
14.
Negative.
So it's
negative 10.
Oh.
So that's right. So negative 10 divided by 5 is going to be a negative 2.
How do you find that mistake? Like, did you just look at the answer key?
I found the mistake because I noticed that.
I thought you said 12 plus 2. I'm like, oh, 14, but it's negative.
All right. And so last problem.
Another one of the
Last problem, and then we'll call it good for today. All right. Bless you. Select a point on the number line that best approximates the location of the square root of 14. Now, Mr. Ferris.
Oh, Mr. Ferris.
Square root of 14. Well, square root of 14 is in between.
Square root of 3 and 4.
It is in between the square root of 9
Of 16.
and the square root of 16. So the square root of 9 is 3. Square root of 16 is 4. So I'm going to be somewhere between 3 and 4.
Yep.
Am I going to be closer to 3 or closer to 4?
I think you're going to be closer to 4.
I think I'm going to be closer to 4 too, because 14 is closer to 16. So let's see where I can put the dot. So,
I think it's 3 and 5/7.
oh, look at that. Oh my goodness. So when I click on that section, I get a whole I get a blown up number line. So now
Magnificent.
it is brilliant, and I'm not allowed to use a calculator on that one.
Cooper, we need you. He's the leadership speaker.
You need to.
Oh, I'm 7th grade represent. Yeah.
Yeah, gotta go represent. Always repping.
Oh, yeah.
Really bad.
All right.
3.55, 3.6, 3.65. I think it's there.
You think it's there?
I think it's there.
Well, I really think that we're going to end up somewhere in the middle. So which one's in the middle? Let's go right about there.
Well, I did it because
And why would you go with that one, Jack?
got no clue.
Well,
I said the one to the left, because 9/14 is 5, 9/16 is 7, so it's 5/7 plus 3 is 3 and 5/7, which is about 3.7.
3.7, which would be right about here.
Is,
Because this is 3.75 right here. That's exactly right. Because 3.7 or 3.75 times 3.75 is going to get really close to 14. Okay, so that's the end of our section. I'm going to submit, and just because we love this stuff, I'm not going to do this whole calculator section. I'll save that for another video. But I am, however, going to go to end this section, and let's see how we did. For all the answers we entered in, we did pretty darn good.
did we enter in 18?
No, we didn't answer some of these. Okay, so there we have it. Because some of it was just, since I don't have a keyboard, it was easier to just write it.